Okay, to that is the sufficient condition for proof करने के लिए, that is what the sufficient condition says, that this is basically, this integral has to go to some limiting value, और limiting value का मतलब है that is less than some less than infinity. Then if it is less than infinity, then that would be basically in fact prove our initial condition. That is the actual orbit it tends to some free orbit. So this is u naught of t psi is less than infinity. This is the condition we need to prove. This will converge if if this if this thing means this norm, this thing does not blow up or diverges. और ये साबित करने के लिए हम क्या करेंगे, वी हैव टू अप्लाई एन इनइक्वालिटी, जिसको हम ट्रायंगल इनइक्वालिटी कहते हैं कॉम्प्लेक्स नंबर्स के लिए. अप्लाई ट्रायंगल inequality. And what is that triangle inequality? So if we have two numbers, two complex numbers, then the magnitude of sum of those two complex number is always less than equals to the magnitude of sum of the magnitudes of those two numbers. That is, if z1 and z2 are two complex numbers, then the magnitude of the sum of these two complex numbers is equals to sum of the magnitudes of those two complex numbers. Yeah, this is basically known as the triangular inequality on right hand side. That is on the right hand side of this equation, जो ऊपर हमने equation लिखी है second term के अंदर. But दूसरे but एक problem ये है कि u of t, in fact this is something which we will use in our favor, that u of ut of s जो है is the solution of some full interacting Schrodinger equation. And we need to remove this, and in order to remove this we can do this because the norm of a unitary operator is 1, or the norm of the unitary operator is unitarily invariant. So this norm is, if this norm is unitarily invariant, then the unitary operator, complex conjugate of unitary operator operating on some vector, then the norm of this operation would be equals to the norm of the vector. That is, when we say norm, so norm is some number, some factor which magnifies or which scales a vector. And in our unitary operator, the norm of a unitary operator is 1. So when we apply a complex unitary operator on some vector, then the norm of this operation would be equals to the operate with which equals to the vector itself. Yeah. So we said, but u of t, so u dagger of s in our case, is the solution, is the solution of full interacting Schrodinger equation. And what we need to remove this. यानी second term को हमें remove करना है. So how can we do this? We can do this uh, because the norm, the norm is unitarily invariant. क्या मतलब है इसका? मतलब है कि दिस norm of something is invariant or is unitarily invariant. I.e., so we have the norm u dagger of S operating on some vector W, then this is equals to the norm of the vector, yeah, for all uh, W, for all vectors. This is true for all vectors, yeah. That is u dagger of S leads to, क्या हो जाएगा? This would lead to minus infinity to 0 ts norm of u uh, uh, dagger of S or v u naught of S. This would be equals to phi n, and this would be equals to integral minus infinity to 0 ds norm of v u naught of S psi n null. Yeah, and this is less than infinity. Yeah, so this is less than infinity. That is, we can argue that this has limit. That is, one can argue that this has limit. Why? Because of these two operators. Yeah, so these two operators would operate on the psi n, and we take the norm of this operation, and what we get is some limiting value. Yeah, that is would be less than infinity. So if it is equals to infinity, then that would not be a limit. So it is less than infinity from the interval minus infinity to 0. So remember, v जो था, that was in fact h minus h naught. Yeah, and so that corresponds to some limiting Hamiltonian operating on the free or free state. Yeah. So this is, if you remember, this is the asymptotic state. So this is asymptotic state, and on this asymptotic state, we have this operator V operating on it, and we take the norm of this operation, and that norm integrated over minus infinity to plus infinity over some time interval S, जिसको S कह दें, tau कह दें, and this would give you the limiting value, not a divergent value, but a limiting value. Yeah. So if it is a limiting value, then it would be less than in fact infinity, uh, and we restrict our so in this case जो हमारे पास यहाँ पर आई है, we restrict our attention to some to psi, uh, and we restrict our attention to sine such that sine some Gaussian function, so that the wave function for this sine is always Gaussian. Yeah, and when we say Gaussian function, तो इसका मतलब क्या होता है? Gaussian function is a function which is described for some traveling wave. Yeah, so what we are restricting ourselves is, we restrict restrict our our attention to sine as a Gaussian function, as some Gaussian function. So the wave function for psi for psi in are always Gaussian. And let that wave function in position space, we define it as x in position space psi, psi in, that is proportional to some Gaussian function which is minus norm of x minus a whole square divided by 2 times xi square. Yeah, where a is the center, and what is xi is the width of this Gaussian function. So if we have